How's it going, everybody? It's Florida Stunners here, and welcome to my tutorial on how to wire an electric condenser microphone. How to make a lavalier microphone for recording with the GoPro, DSLR camera, your smartphone. Now, on this video, I'm not going to be actually soldering or physically making any microphones. I'm just going to go over the paper stuff, go over the circuitry and how it works. Later on, I will make a video and actually show you guys how to wire everything and how to get a functioning microphone. Now let's start off with an electric microphone. What is an electric microphone? An electric microphone is a small microphone that can be found in laptops, smartphones, video or audio recording devices such as tape recorders and, well, a lot of things. Now these little microphones, they're very inexpensive. You can get these on eBay, digikey.com, Amazon. There's a lot of places you can get them. I got about 50 of these for, I think it was like $10. Now, these microphones require power to run. They require anywhere from 1.5 volts to 12 volts. Now, the specs, when you buy these microphones, it'll tell you how much it needs to function properly. But it's pretty safe to say that somewhere between 1.5 volts to 12 volts is fine. In this video, we're also going to be talking about resistors. Resistors, the battery, which is the power source, and capacitor. Now, one thing I want to go over before we begin. On this capacitor, you can see that on this side, there is a gray line with little dashes on it. That is your negative lead, your negative side, your negative terminal. On the other side is your positive. Now this will be critical. I will show you guys later why. So let's get started. Now there's different ways you could do this. I'm going to show you two very simple ways. The first one being a very straightforward connection. And this connection just requires you to connect a wire from the microphone to whatever jack you're going to be using, whatever connector. Now you would just connect the positive to the microphone portion of your connector and the negative wire to the ground. Now this is straightforward. It works with cameras that already provide power, such as GoPro. GoPro provides somewhere around 2 volts of electricity to the microphone that will power up the microphone and let it function properly. Some other recording devices such as smartphones also do this. Now I'm also going to go over a different method, which is using an external power source. Now this looks a lot more complicated, but don't worry, don't be scared. It's very simple. Now here we have our electric microphone. We have the positive and the negative nodes, the terminals. Now what we got going on over here is we have 9V for 9-volt battery. I use a 9-volt battery to power my microphone, and this little squiggly line is a resistor, and in my case I'm using a 2.2 k ohms. That means 2,200 ohms resistor, and it is a quarter watt resistor. You could use, there's different values you could use. There's videos out there, and Google search could show you about the different values and how to use them together. I'm not going to go in depth with that. I'm just going to give you the two values that I use, and it's pretty straightforward. You guys could use this and it'll function exactly like the microphone I'm using. Now, so this microphone requires power to work, and we want to provide our own power. So what we're going to do is we have a 9-volt battery, and the positive terminal is going to connect to the positive terminal of this microphone. Now in between it, we're going to add a resistor to restrict how much current is flowing in here. I use this 2,200 ohm resistor. So pretty much we draw current from this 9-volt battery, direct current. Now we don't want this current coming back out and going to the camera. That could ruin the camera. So what we do is we add a capacitor. Capacitor lets current to flow in one direction. And now what this capacitor does, it's going to block this direct current. It's only going to allow the alternating current from our voice to go through. So in this case, I'm using a 10 microfarad, 10 UF, 25 volt capacitor. Like I said, with the resistor, there's many variations of this with different resistors, different capacitor values. You guys can test it out with different values if you guys like. this is what I found works best for me. So what you would do is get your 9-volt battery. You connect a wire from the 9-volt battery to your resistor, one side. It doesn't matter which side of the resistor. And then the other side connect it to the positive terminal. From there you'd have a wire coming out past the resistor and going to the positive lead on that capacitor. So like I showed you guys before, we have these two leads on the capacitor. The longer one is the positive, and then you got the negative with the little gray area and the little negative symbols. Now this is crucial. You need to have the positive side in the right direction, because it only allows current in one way. If you were to flip this around and put the negative on this side, it could blow the capacitor. The capacitor could blow. Now, if we flip it the correct way, it'll function properly. No harm will come. And mine's rated at 25 volts. We ain't gonna be using anything over that. This is fine for this, for the use of this. Now, if you were to go over the voltage, it could blow as well. So what you do is connect the positive side over here, and then the negative side to the other side of the wire, and you go on out to your output. This would be your positive terminal at the end towards your jack. And the negative wire, goes straight out into the ground connection. Now you might be wondering, the 9-volt battery has a negative terminal. Where does that connect? Well, it's assumed that you connect that to your negative wire. So you could connect your positive side to the positive wire, your negative side to the negative wire. Anywhere along this wire will do. And that's pretty much it, guys. Now I have seen that using my own power source so far, a 9-volt battery has definitely increased the quality of my audio recordings. Adding this circuit made a big difference compared to this. Now in a later video I'm going to show you guys how to add a high pass filter, and that'll reduce the sensitivity of the microphone. It will also help cut out some of the lower frequencies, unwanted frequencies, and help you focus more on the vocal range for recording audio. Now if you guys are recording audio that requires background ambient sounds, you might not be interested in this, but in my case where I'm only doing audio vocal recordings, I want to focus more on the vocals, so I'm going to add a filter. Stay tuned for the next video I put up. I'm going to be talking about adding a high pass filter, and then in the videos following that I'm actually going to go ahead and make a functioning microphone with you guys and show you guys how to make one. If you guys have any questions, feel free to comment, message me. I'm willing to help, and I would love to help anybody make a microphone if they want to for their own device. It's very fun to do. Making your own microphone is very gratifying. Now subscribe, share, like, comment. Stay tuned. If you guys are interested in this and to see where it goes, stay tuned. I'll be posting more videos within this week. I hope you guys liked it and enjoyed. Thanks for watching.